Hello and welcome back. As Lee had said at the end of the last video, in this video we're going to get the new grid shape up and rolling. So this is going to be implementation part 1.
Right. Now, the fun thing with this implementation is not so much that we're adding new code as removing a lot of code. Because we had to do a lot of manipulation and massaging to get these alternating vertex counts on these rows. So all those extra conditional checks to see if we're on even rows as opposed to odd rows, we get to remove. So the first part of this is going to be going into the construction of the vertex lattice for the grid and simplifying it. Now, the cool thing is we're simplifying the number of vertices that are in our mesh, which means our mesh will be less dense and it'll render faster. It's not an incredible number, though. I mean, even for something like this, which is, I think, a 9 by 9, we're only saving 1, 2, 3, 4 vertices. So
True, but we are removing the conditional checks that were constantly going on. There's, even though it's not something that's going to be very apparent, it is still an optimization.
Right. But if you saw the code that I had to go through to implement something like the smooth sculpt tool,
dealing with having those extra vertices in the patches,
dealing with those extra vertices and getting everything to line up and to make sure that not only that the extra vertices in this one match, but the patches in the adjoining, or the vertices in the adjoining patch also matched up with these.
Oh, I bet that was fun.
It was actually a couple hundred lines of code of try and catches to go, well, if it's here and not there, it was just a mess.
Wow.
So
we're going to actually be simplifying our lives in several ways by doing this.
Right. As things go forward from this point, it will make things much easier. So the only problem that we incur with using a shape like this, and I have to admit, I got to give credit where credit's due. There is a thread that was started, I believe, by Avachi, who was discussing whether or not we could use diamond-shaped grids, because he kind of liked the shape of this, but he was talking about what if we trimmed off this section over here and added it over here. So basically it was a square grid that was slanted to the side. But then Tomo came up with the idea. He had taken the initial grid that I had proposed, which looked like this one. And he had gone in and painted the extra edges off and going, would something like this work? And I think Avachi came back and said he wasn't sure, but then nobody ever brought it up again. And it just goes, huh. It just kind of sparked the set the little light bulb going, and it's like, you know what? Because I'm not using LOD, this is going to work perfectly.
Nice.
So by doing this solution gives us a very simple, elegant solution to our terrain patch, and it works in our case because we're not worried about LOD. Now, if your implementation, you're looking at something that is going to use level of detail, this solution is not going to work very well for you. You're going, unless you did something like created a geometry skirt that stood in between this and the next patch to change, to modify the LODs, which is something I played with, and in Unity is just too slow to work real time. So you'd have to pre-calculate all those and then have those cached out. So, but because we're not dealing with the complexities of LOD, this is going to simplify our lives greatly in the beginning when we're constructing. And I kind of wish I knew this back, when I first started the testing. But who knew LOD wasn't going to work for us?
Oh, it's all about R&D. That's why we're doing this stuff.
Yep. And in the future, with our sculpting tools, our painting tools, it's just going to make things easier.
Awesome.
So let's go ahead and start setting up some things so we can play with this. I'm going to jump over into Unity, and if you guys are following along, you probably have your water in here and it's turned on. I'm going to turn it off for now. We don't really need it for our test that we're going to be doing. And I want to go into code, and I'm going to go into our patch vertex count, and I'm going to dial this down to 5. We don't need a lot of vertices just to test to make sure this all works.
Right.
So, and this will speed up our load times as well. So if I go ahead and jump in, hit play, give it a sec, jump over to scene, and let's frame up. So we've got actually a few more patches than I want. So we've got, looks like 25 total patches. So let's drop that down as well. And this one, let's change that down to 3. I know my icons, really. And come on. There we go. And frame up. There we go. And that did not compile because I hit the wrong one. What did I do? Vertex count 3.
Did you want your patch row count changed?
Yeah, I wanted 5 here and this down to 3. There we go. That's what I want to see. All right, so now we have 9 tiles, or 9 patches with 25, well, actually, they're not 25 vertices each because I've got 2 extras now. So let's go ahead and start changing up the shape of our terrain patch. So if I jump over into code.
Awesome. F18, I take it?
No, actually, I think that is a leaf blower.
Oh. Well, sounded kind of like one of those low-flying F-18s.
No, the F-18's got more bass, and usually the windows start rattling a bit.
I gotcha.
So that's a little bit high-pitched, and, you know, as much as that is moving around in my auditory space, that F-18's like doing figure 8s right above my house.
Gotcha.
So I guess the yard guys are out there doing their thing.
I see.
All right. So where we need to be is inside of our terrain patch file under create grid. So this is our first area. And if you look, we've got code that is dealing with whether or not we're on if Z is even or if Z is odd. So we're dealing with our even and odd. So the cool thing is we don't have to worry about odd anymore. They're no different than our even rows. So we can go ahead and delete all this. Code's already simpler. Look at that. So we don't need to do our conditional check. All right, now what I do want to do is adjust our spacing calculations a bit. Now, one of the things that we're going to do, actually, let's just build it out this way and see what we get first. We'll do this step by step. And Unity. I will learn those icons one day.
I know you're getting a little better. Whee.
So, first problem. Some indices referenced aren't going to work. I expect that to happen. because we are now building a different number of vertices as opposed to having the count. So it's trying to draw those grids based off of, or our patches based off of the other vertex counts, which we don't have anymore. So let's go in and open up our demo. Let's go to our train demo file, which is our main one. I'm going to modify something here real quick. So I want to create a new train patch. So I want this line of code here. And let's see, what is this one? Is control KU? Is that it?
I think C.
Control CU?
No, Control K, C.
Oh, for comment. Yeah, that's on. Yeah. What did I do to it? I did something to it. There we go. I made it really mad, though. Yeah, I sure did. Alrighty. What I'm doing is I'm taking out all of the other patches. And I'm only going to create one patch to start off with.
Okay.
And the other thing that I want to do is here. I'm not going to update our train patches. So I only want to create one and make sure that we're building our vertices, but I don't want to create an object from it because that will just fail. Because until we adjust everything, we're not going to have enough information to create it successfully. But what we can do is inside of our loop, we can do a game object dot create primitive, and it's not going to give it to me. Primitive type. Let's create a sphere. And let's adjust some stuff on our temp game object. So take our temp game object. Let's set its transform dot position to be equal to our, let's see, I'll just copy this line again. It's not the most efficient, but it will give me what I need. What I want to do is I want to position a sphere where each one of our vertices would be at, like we did way back when we first started this. And I'm going to adjust its local scale to be equal to new vector 3, say 0.25. All right. Let's see if that gives me what I want it to do. So hopefully it gives us something to look at without errors. All right. So that part works. All right. So now we have a nice little grid of triangles.
Right.
Actually, I screwed up. You know that?
Did you?
Yes, I did.
How so?
Because we do actually need to keep track of alternating rows.
Okay.
I forgot all about that. It's like, you know what I missed, and the reason why we have to keep track of alternating rows, we have to off shift or shift each alternating row still, because we want the equilateral triangle still.
Okay.
So that's easy enough. We can go back over here, try and patch, but I still want this. So I'm going to copy that for now. And we'll hit Control Z again. Follow my notes. Don't second guess. All right, so we're putting the alternating rows back in. But because I've saved that out, I can still put that code back in. And I will take this code and I want to put it in for each one of these, because we're going to have to do it for each condition.
Right.
All right. This is why you do visual stuff, and so you can test it and see if you get what you expect it to do. All right. Now, there we go. I'm just looking at it sideways. I'm using this to line up the front of the world. So we're getting an extra row, and we're not offshooting yet. But we're starting to move our dots around.
Are we? Are
Yes. Yeah, because of the way I did the calculations.
Mm-hmm.
Whoops.
Hang on. You're wanting to just go back over here?
Yeah, I want to go back in the code.
Oh, in the code.
Yeah, because right now we've got that extra pixel still being generated,
Mm-hmm.
because I've got this extra +1 here.
Mm-hmm.
And I need to use this version of our offset down here. So if we go here, all right. So I've got the right offsets. We've killed off that extra row,
Mm-hmm.
which would be right down here. So we've got the exact number of dots. Now we have to deal with this guy as well.
Okay.
So what we're going to do is try to get back over in code. There's a few things that we don't need for the first part of this condition. Deals with our even rows,
Mm-hmm.
which is mostly how we're going to end up with all the fun stuff, and off or shifting of all of our positional stuff happens here, which we don't need anymore. We also don't need to calculate our heights differently than, because right now it's checking to see if we're on one of those edges and calculates our height differently based off of if we're in the middle of our mesh or if we're on one of the edges. So there's no difference anymore. So we don't need this conditional. So we don't have to average. So that'll be the same. Now our UV stuff will still be calculated the same. Here, we're still going to have some issues that we're going to have to address. Wrong button. Wow, that was really awesomely fail.
Did you want to go to Unity?
Yeah, I'm working on it. All right, there we go. So now we're getting closer.
Mm-hmm.
We have the zigzag edges.
Okay.
Now, that gives us what we need. We can still see that we've got some three-dimensional height to this.
Mm-hmm.
So there is still issues that we're going to have to come back and address but those aren't going to be readily apparent until we draw a mesh as opposed to some dots. Because if I select these, yeah, we might be able to see it, but it's still going to be hard. Let's see if I can. Basically, the problem comes up is we're not centered up on our world origin or on our mesh origin, and we're going to have to deal with the way this is all spaced out.
Okay.
But once we start drawing the mesh, that should become easier to see. But we'll do that in the next video.
All
So
right.
all I really wanted to do, and I'm going to go back into code one last time, make sure, because we will have to come back and adjust something, but I want to adjust that when we have the mesh drawn.
Mm-hmm.
I want to make sure that there wasn't anything else that I'm missing right off the bat. Nope, that should be it for this
Okay.
part. So we
Awesome.
will, like I said, we'll come back and we'll fix that last thing once we can demonstrate the problem, but that will be in the next video.
Okay. Well, with that, that is going to wrap up implementation part 1.